Okay, so this lesson is on complex fractions. So basically, if we have kind of fractions in fractions. Okay, so let's start off without variables, just looking at numbers. If we look at this, there's kind of two major ways that we can tackle this problem. The first would be to find common denominators, combine the fractions in both the numerator and the denominator, and then we have a fraction and a fraction. What do we do with fractions and fractions though, right? So if we have, let's say 2/3 divided by 7/6, well, what we do with that is we keep, change, flip. So we keep the top the same, change what we're doing. So before we were dividing, so we change it to multiplication, and then we flip. We flip the bottom fraction. Make sure to always flip the bottom one, not the top one, not the first one. So then from here, we just simplify, right? So 3 goes into 6, leaving us 2, multiply across, so we get 4/7, okay? That would be kind of how one way we could tackle this. The other way is to get rid of having those little kind of individual fractions. We don't like that there's a 3 here, and we don't like that there's a 6 here. So let's get rid of those. If we can do that, that would make it so that we don't have fractions and fractions. We just have one overall big fraction. So what we want to do with that is we want to find the LCD of those little denominators. So 3 and 6, well, the LCD there is just 6. So what we're going to do is we're going to multiply every term by 6. So multiply here by 6, multiply here by 6, here by 6, and here by 6. And then simplify. So right here, 3 goes into 6, leaving us with 2. That one, nothing to cancel. That one's fine. 6 goes into 6, completely goes away, right? Now just simplify what we have, basically by multiplying. 7 and 2 make 14, minus 3 and 6 make 18, divided by 2 and 6 make 12, plus, well, we only have 7, so that's it. And then combine like terms. So 14 minus 18 is -4 over 12 plus 7 is 19. -4/19 would be our final answer for this problem. Okay, so basically there, we just got rid of the little fractions by getting rid of the denominators and multiplying by that LCD. So what if we had it a little bit different kind of thing? What if we added variables into this? So let's start off with a slightly simpler one. Okay, so this one is just a fraction divided by a fraction. So it's going to be exactly like what we did kind of before in that little problem. We're just going to keep, change, flip. So x over 4 times 2x plus 6 over 3x. Now we should notice on this 2x plus 6 portion, that's factorable. We can factor 2 out there. So that would be 2 times x plus 3. Now we look to see what we can cancel. We have an x over 3x. Well, that x cancels. Then we have 2 over 4. Well, the 2 cancels into the 4, leaving us with 2. So what do we have here? We don't have anything here. We just have x plus 3 up top. Then we have 2 and 3 in the bottom, so that's just 6. This is our final answer. We cannot simplify this anymore either. So just because there's a 3 and a 6 there, we can't do anything more. That's it. So next is kind of going back more towards this first one that we had, but with variables still. So 2 minus 7 over 3v, all divided by 7 over 3v minus 5. Now with this one, again, we want to get rid of those little denominators. The little denominators are the same though, so the LCD is just 3v. Again, multiply by 3v on every term. So then let's simplify. The 3v's cancel. both places, and then we just multiply. So 2 times 3b is 6b minus 7 all over 7 minus 15b. How we know if we're done or not is look at the top. Can we factor the top? 6v minus 7. That's prime, right? We can't factor anything out of it. 7 minus 15b. That's also prime. And they're not the same thing. So we're done. We can't cancel, we can't factor, nothing else to do. So then next is if we kind of take it one step further and have different denominators with variables. So that would look something like 3 over 25 minus 3 over 5x, all divided by x over 25 minus 1 over x. So again, look at your denominators. We have 25, 5x, and x. Well, the LCD of 25 and 5 is just 25. However, we have the x on there, so our LCD is 25x. Again, multiply every term. So, 25 into 25x, just the 25's cancel. We still have the x. 5x into 25x, the 5 goes into the 25, leaving us 5. The x goes into x, taking it away. 25 into 25x, again, just leaves us with x. X into 25x, the x's cancel. So then what all do we have? So we have 3 and x, so 3x minus 3 and 5, so 15, over x and x, so x squared, minus just 25. Now we're not done because these are factorable. So 3x minus 15 has a 3 in common, leaving us with 3x divided by 3 is x, minus 15 divided by 3 is 5. The bottom, we should notice, is a difference of squares because it's x squared minus 25, which is 5 squared. So that means we have x and 5, x and 5, one of them's a plus, one of them's a minus. Then the x minus 5's cancel. So really our answer here is just 3 over x plus 5. And we know we're done again because we can't cancel anything else and we can't factor anything else. So there's one last kind of type we can get with these problems, is if we start off with negative exponents. So if we have something like a minus b negative 2 over b plus a negative 2. Well, we should rewrite this first. So we don't want negative exponents. Okay, basically our goal in this problem is to simplify with positive exponents only. So, rewrite it, a minus, now the b negative 2, that negative 2 is only on the b. Negative exponents mean we move it within the fraction, not within the big fraction, because it's only on the b, within b's fraction kind of thing. So it's 1 over b squared, over b plus 1 over a squared. Okay, so with this one, we're going to again find the LCD. A squared and b squared have nothing in common. So just multiply by a squared, b squared, right, on every term. So then still times a squared, b squared, and cancel out what you can. So b squared cancels out b squared, and a squared cancels out a squared. So a times a squared b squared, that would be a cubed b squared minus, well, 1 times a squared is a squared, over b times a squared b squared is a squared b cubed plus b squared. Now technically we can factor that, so we're not done on this one yet. Because if we look at the top, both of those terms have at least a squared in common. So that means we can factor out a squared, leaving us with, well, a cubed divided by a squared is a, and also b squared still, minus, well, a squared divided by a squared is 1, over, bottom has b squared in common. Factor out a b squared. That would leave us with a squared b plus 1. Now, a squared over b squared, can't cancel anything there. ab squared minus 1 and a squared b plus 1, can't cancel anything there. And neither of these are factorable because they're not difference of squares, they don't have any more GCF in common, right? And it's not a quadratic, so we're kind of out of options. That is our final answer. Okay, so that's complex fractions. Basically the goal with simplifying complex fractions is to not have any negative exponents and to not have any fractions within fractions. So you want just one overall fraction. Okay, that's it.